know I'm not the easiest to love. I thought I would at least be worth a shot. Instead you gave up on me 2 months in, 'cause my flies were too hard to deal with. Did you even love me in the first place? In the first place? If you did, we wouldn't be in this place. In this place, I wouldn't be here trying to say I'm sorry for parts of me. Did you even love me in the first place? In the first place? In the first place? Storyline like an open door. In every way I could have seen it going there. Will it end this way? I framed the night like it's hopeless love. Realized we could have it all, but now will it end this way? Our dream won't be wiped out. The silence been muted after all. Our dream won't be flying out, 'cause we won't let it bring us down.
All right, and we're live. This is actually the second attempt, so let's see how that goes. Hello. Yeah, hi. We're building a 3D printer. Welcome. So, nobody here yet? I guess if anybody watches this, then probably in the review and recording that hopefully doesn't get lost somewhere along the way. Yeah. Anyways, I just want to build a 3D printer. In this case, we're building a Voron 0 in version 2 R1 in a Fysetc kit variant. For today, I'm guessing we're just gonna look at the box, check what's in there. I already grabbed a few things out of it. Look at the parts, look at the manual, go through the manual, and do some heatset inserts. Yeah, and once we're done with that, we can probably do some frame building and squaring. That's just about, I think, what we can manage today. Maybe look at some rails. No hurry. This is dirtling, right? So we're not aiming to get anywhere. We just want to do things. All right, let's have a look at the kit. For that, we'll, I guess, switch to our top cam here. And what you can already see are the rails. I kind of fiddled them out of the case already, out of the box, because they're in there so tight so nothing happens to them. It was better to just get them out. They look fine. The color, the quality of the anodizing looks good. They anodize them post cutting, so you actually get the anodization on the ends as well. Not sure how much of a difference that's gonna make because they will likely be covered, but yeah, looking good. The one thing that they don't do is no drop nut inserts because of the way they are shaped here. Right, the what is it? This is open builds. These are the maker beams. Actually have a V shape or something, if I understand the internet correctly. Not that I ever had any in hand, right? This only being my second 3D printer, so expect more carnage than anything else here. So yeah, moving on. So this is kind of fun. I'm not sure if we're going to use that in the first part of the build. We may mod that in later, but I do want to try to build as stock as possible, I guess. We'll see how that goes. Yeah. Otherwise, this is what we're working with. Big box. Actually pretty small. The one other printer I built previously, a Trident, also by Fysetc, had a way bigger box. But obviously those builds I can't stream because this is the only area we have. And yeah, 300 Trident doesn't fit here. The box. We got some panels. They look fine. People have reported them being a bit thin, but we'll see about that. Shouldn't be a big deal. Otherwise, cuts look fine. That's cool. Not that I know, right? I'm actually a game developer, so what do I know about manufacturing? Some cables. I already took these out of the box, so we can show them off better, and I don't have to deal with those. A few cables. 75 watts of a heater, kind of nice. More cables, thermistor. Oh no, yes, actually. Yeah, so this is your thermal fuse. We've got a very weird bit here. Kind of curious where that goes. And LRS 150. Your typical one. Nothing special. Pretty stock. For modding and stuff, I would have probably preferred a 200 or something, but I guess space is at a premium. What's really cool is this. It is heavy, so I'm not sure if it needs to be this heavy, but compared to the extrusion build variant, this will likely sag way less because cantilever printer. Right. Some Wagos, PI sheet, the magnet, and our bed. Yeah, looks pretty decent. In general, though, to be honest, while I haven't had a kit from LDO or Lecter or whoever you want in hand, I'm not sure what the difference will be in quality on those parts. The heater I can see, and potentially the bed. But many parts of a 3D printer, actually not so much dependent on quality. Nowadays, the qualities from the cheaper kits seem to be pretty decent as well. All right, we got a couple of motors. I think they are Fysetc branded. Your typical NEMA 14. No problems whatsoever on the Trident. They work just fine. Yeah, not gonna take all of those out right now. We can look at them when it's time. Screws, springs, and the like. We're gonna put that aside as well. Maybe we need something from that in a moment. Cables, I guess, are one source of potential issues that you may want to replace. But I haven't had to yet. PTFE tubing and power cable, I guess, is nice. And then we have our controller board. So, contrary to the bill of materials, this is a completely integrated board. So you have your controllers, you have your drivers, still step stick. They actually weren't installed here before. I already did that. And then you have your CM68. That's sadly not, I think, Pi 4 compute module compatible. But I've yet to hear anything bad otherwise. I think it's a rock chip. So, pretty fine. The umbilical here is pretty interesting because it... let me see if I can find that. It delivers just about everything we need to the print head in terms of power, in terms of control signals, and anything else. So that together with this board make up the whole electronics. Pretty cool. Although we will be modding this to CAN bus. I'm a pretty big fan of CAN bus. I like how it behaves. I like how extensible it is. And this actually has a problem. If you look at the connectors, you will realize that, for example, LEDs are completely missing. We're gonna fix that. We're gonna fix that pretty easily. There's just one additional wire we need to run here and maybe a few crimping things that people don't tell you usually. But yeah, that's fine, I guess. Otherwise, pretty stoked to have it. In the final version, I do still plan to go with a mellow SHT36 and very likely an octopus. The reasoning we can talk about later. Suffice it to say that Dueling Zero looks quite nice. Yeah, let me put this aside. Back in here. Yeah, some zip ties and pliers, and this is the umbilical cable, so pretty cool. And it's actually quite short. I don't think people realize how small this printer is until they see the build plate and the umbilical. This is basically all the range of movement that printhead will ever need, and it's awesome. Yeah, we got a pretty sizable screw kit. The Trident came with an actual case. Let me see here. This is what the Trident came with, so a bit nicer. But I will likely sort all those screws into their actual final bins anyways. I'm not a big believer of working from these. It's not sustainable. Yeah, a few more cables, drag chain, fans. Fans will be an issue with this kit as well. So we're not even going to use these. I ordered some Sunon fans because sadly this is one of the shortcomings that you may be better off with a higher quality, or well, I wouldn't even say higher quality, but higher priced, higher regarded kit. So yeah, with these kits, Fysetc is very much skimping on the quality of their fans. It's just the way it is. Belts. I haven't heard anything bad about these. And cables. Cables also something to look out for with cheaper builds like this. I don't believe these are necessarily bad, but you need to be a bit careful with them. The most important thing though is anything that's to do with mains voltage. The very first thing when we wire this up that we're gonna do is get rid of these and replace them with ring terminals, just to make sure they are secured. And then we will also need to think about a way to earth connect those. Yeah, fun times ahead. What else? Oh yeah, rails. Fysetc branded. Yeah, nothing much to say about those. When I took a quick cursory look at those rail end stops were missing, or at least were not in position at on 2 of those. Nothing bad happened because they're still kind of secure, but check those first. Might be the thing to do. Rails we will need to lube. Maybe take the carriage off of 1 or 2 to see what the quality is. Yeah, nothing special. But well, actually, on my Trident, I do have a few issues with rail quality. Mainly that the deflection of my X and Y rails is almost 0.1 each, which means that even if I perfectly align and square the build area, I have almost 0.2 deflection in the middle, and that kind of sucks. But it's 3D printing. It's snorting plastic in a molten form at 250 degrees out a 0.4 millimeters big hole, and hoping that it's landing somewhere where we can build. So I guess it doesn't matter much. Push comes to shove, there is a bad mesh. So yeah, that's the kit. That's what we're gonna work with. Let me get this sorted back real quick. Let's keep the screws outside. I think that should be it for now. That should be all we need. Let's move on to checking the manual and getting some heat sets into the thing. All right. So, printed parts. Obviously in a project box. As always, sponsored by Polymaker. Not this video, but my project boxes usually end up to be sponsored by Polymaker. And we're doing this in Polymaker yellow and Polymaker teal. These look pretty awesome. You see, I already test fit some stuff. Some stuff we will build later. right? Like for example, this Nevermore version 6, also with Xenon fans, and not from a kit. More on that later. Also the display, that I mainly test fit because there is a bit of an issue with my salad fork kit that I'm planning on building next, if this works out properly and well, potentially on stream. Otherwise, I don't mind building it at all alone. Yeah. Printed parts, otherwise the obligatory cat ears that just needed to be done. Yeah, and we're going to use, eventually at least, we're going to use a Fetus Dragon hot end. We are going to use the stock hot end first. This is moved over from the salad fork. Mainly because the salad fork needs a 0.4 nozzle, and I only have 2 of those that I want to use. Printing mostly with Diamondbacks, and obviously I don't have too many of those. I had an old set of MK8s. So the salad fork is actually going to use a Creality Spider Pro hot end. That's going to be fun. I have never tried those as well. All right, yeah. AB motor mounts, the inlet mount look all pretty good. Nothing to complain in there. And here is the hot end we're actually going to use it at first. That, by the way, was also included in the kit. I just took that out to test fit it already. Yeah, so those are the printed parts. Let's see what we need in terms of heat sets, and let's go through the manual and see what we're building. There we go. That's the printer. That's what we're going to build. And I need to make the audio fit wire. There you go. Yeah. So pretty standard printer. I guess most of you know this already anyways. This is not meant to be all that much of an introductory stream. I just want to build it. And maybe I have some comments here and there. So we get an explanation of what's what. Self-tapping screws and so on. Shims, bearings, bearing stacks probably later. Obviously this build, as many other Voron builds, will use spline joints because those are cool. And they're very, very good way to connect extrusions without actually influencing the stability of the extrusion itself too much, I guess. Not sure how much these flanges will hold though. It's like, again, not a mechanical engineer. I may just be talking out of my ass here. All right. So drilling is not necessary for us, but I guess we need to look at our extrusions now. Oh no, we want to go through this and look at the printed parts first. One thing at a time, one thing at a time. I'm gonna already heat up the heated insert press, and I am going to grab the heated inserts from the screw bags. Let's see what we have here. That's not too many. I guess this will be fast. Standoffs. Oh, the bed mounts. Self tappers. All right. So, moving on. These we can't use. Nothing here, nothing here, nothing here. So basically this printer is going to be built by building the square first, putting the rails in for the bed. Leaving the front of the squares off, and yeah, at some point I guess putting in the front to lock it down. This part we're not gonna build because we have the CNC version. We also don't have a front. That's fine, that's all fine. Yeah, but that's how our bed will be mounted. Cool. Don't need that either. So from a heatset insert perspective and from a printed parts perspective, we're pretty good off. Good job, Fysetc. Although I do want to grab the one part that is shown there, just to check that it's there. Yes, there we go. Cool. Now, that's still the drag chain, so there's still nothing to do for us. Nothing to check. And I'm going to put the irrelevant stuff here. And obviously I'm going to drop the display, because what else should be dropped? So that's one of the parts we will need in the beginning. This is where we slide that in. And now we're getting somewhere. So what we need is AB motor mounts. The higher part, and we can already see these 3 holes likely need heatset inserts. Small holes we likely don't need. We'll see. Oh, there are some here. These 2. And we should also have another high AB motor mount part. Not that. Oh yeah, there you go. So the soldering iron is up to temperature. Let me move this away. Let's open these up. Let's see if they fit well. Yeah, that works. Actually, from a tolerance perspective, I guess the Trident did well. And let's grab our heatset insert press. Let's give you a bit of a better view. There we go. By the way, something I don't really understand. There are so many people building heatset insert presses. This is a Dremel workstation. Every single creator probably has a Dremel. I'm really not sure why they're not getting one of these. Because they're awesome. You get a stable work platform and yeah. Don't need to build much. The printed part is very small to adapt this to a heatset insert press. Anyways, the thing we want to do here is not press. We want to heat up the insert so it slowly slides in. And I guess this one is fine. Not the most talented person with these. I actually tend to press them in too far, like this one. But that is probably not the fault of the press, but me just seeing shit. You know how it is. If you get somebody building a Voron, it's probably some kind of middle-aged to very old person. In my case, with bad eyesight. No, I'm kidding. Yeah, that last hole doesn't actually line up all that well, but I guess we can still make that happen. And by the way, these are kind of at an angle still. What I should do here, and actually let's is put our parts in a proper desk vise. There we go. And I guess we need to move this up a bit then. There. That's better. And yes, I do have some issues seeing. So if I can actually build this, then just about everybody can, because I have a few handicaps here. Well, that looks fine. And that was too loose. All right. Any other places? Let's check our manual here real quick. Nope. Doesn't look like it. I guess we can do the other side. Put that in there straight. Grab 3 of the heatset inserts. And just go. Waiting to heat it up and slowly press it in. Yeah, that's fine, I guess. There we go. And we're just waiting to heat it up. Pressing it in. Here we go. Actually, I'd want the outer ones to be a bit further down. There's this little lip that formed because we were pressing those in. The outer one's actually way too far out. And I mean, the manual will indicate if they need to be completely under. There are a few places where that's actually required, but I guess it's better to have them a bit further in than too far out. All right, cool. So, moving on. 2 more finished parts. Now there's the side heatset insert. ABS fumes. Don't do that. I actually have an air purifier running here, so making sure that I don't hurt myself. Yeah, make sure that you're safe. There we go, that should be enough. And I guess that is in. Next part. Nice. What's next? We also need these. So they go on the pile. That heatset insert we did. That's all nice. What we don't have is the measuring tool that I already see here. I don't think we're gonna need that. We are going to use some precision calibers. That should be just fine. No printed parts, no printed parts. The screws. There we go. Present and accounted for. That's the other side. We already did that. There's really not a lot to this printer in terms of printed parts. Even when printing those on the Trident, on the 300 bed, these were 2 prints. So pretty cool. Some fitties. The A and B returns or idlers. I'm pretty sure there must be some inserts in here. So let's look. No. Damn. That's not to say that I'm disappointed, it's just not expected. And I'm kind of guessing that the microphone is picking up all that noise. So sorry if I'm annoying here. Might need to use some noise cancellation. There we go. This. And this is the other one. There we go. What else? That part's here. Also looking pretty good. Although I printed all of these with quite a bit of squish, so they may need to be cleaned up later. But again, no heatset insert. And that looks so awesome. That's gonna be fun to build. Finally something to do. The inlet mount. Few issues on the overhangs that we need to clean up, and there is some warping here. But yeah, it is what it is. We're gonna make it work. Now the challenge here will be, we have a flat surface for registering, but we need to move this up. And this, by the way, one of the disadvantages of this whole thing. It is somewhat limited in range. Not too much, but still limited. All right. Heating that up. Slightly pressing it in. Yep, slightly under. I guess that's fine. I know others tend to then use like a cold piece of metal to inset those, but no. It still does a job. The most important thing is to clean up that lip. And actually, in this case, we will need our vise again, because we don't have a straight surface here. Could make it work, but why? The right tool for the job. Sorry. And slowly pushing that in. Well, gliding it in. You shouldn't push these. Awesome. Well, slightly above. There we go. That's how it's done. Now the question is, yeah, feet need heatset inserts as well. 1, 2. The feet, by the way, we are using the non filament sensor version, because we do have a filament sensor in the head for the ERCF later, and I don't think I need another one. It's the less switches on a printer, the better. I'm not religiously trying to go like sensorless or something, but if I can leave a switch off and then just print more carefully, then I will. See, let me get that in here. That looks kind of straight. And again. Oh, so close, but no cigar. Let's move that down. I guess that could be better with a proper heatset insert press. Nicely done. Need to praise myself. Something I learned with training dogs. Praise and acknowledgement is important, and since nobody's here from you guys, I need to praise myself. There you go. That's logic. Yeah, that's pretty good. Trying not to touch these too long, because obviously they're still hot. Many a streamer forgot that, and I probably will as well at some point. And hopefully I don't burn down the house then. Yeah, but I guess I will get into a situation where I burn myself at least. Not that there's not a pretty good chance that I will don't burn down the house. I mean, I'm a software developer. I'm not expected or required to have manual skills. It's kind of why I chose the profession, so. All right, so Fysetc got their inserts. In this case, we also have an insert in the side of the filament sensor version. I'm hoping that I don't need that. And I hope I printed the right feed. Well, actually, I see. Okay, so this insert is likely to secure the bearings in there, or something along the line, and we may not need that. Nice. Cool. Then those go together there. No need for inserts anywhere. No inserts here either. And this is pretty much how the printer goes together. Okay, so here we need some inserts now. Let's find that part. It is this. And this. Well, actually, these may still be different. Let me look in the project box. That looks awesome. That's the top. No, actually, those are the ones. All right. And I really hope I'm not annoying you guys here. Put that in. I may have to look at what I can do to remove or reduce the noise for the tools and such. I was actually planning on having separate microphones to pick up some of the noise, but not all. But I'm guessing that's actually much better spent removing noise. And I'm in front of you. And there you go. Heating up, pressing it in. There you go. Nice. And another two. Yeah, no, I think they need to go in a bit further. Let me see if I can give you a better angle here. There you go. We will definitely need to cut away that lip. All right. Moving on. Now we have these parts that we just did. Those go together this way then. And by the way, pretty good to always check the manual beforehand. See how things go together in case you have any things that are unclear, basically. It's good to know how things go together before you build it, so you can have some idea and some basis for reasoning about how things should go. All right, I think that's it for the basic printer. Moving on to the tool head, I guess. And for the tool head, let me see if we get something to work here, because I'm majorly annoyed of having to switch the cameras. There we go. That one. Nice. So, tool head, that's that. We already removed the support. There we go. Should be good. And let me check something on YouTube right now. Because I would have kind of expected at least somebody to randomly stumble up on this. But, oh well. It's not like I can't do this alone. Although I would appreciate your guys' input. Maybe in the next one. That would be awesome. It says we're live, so I guess we are.
You love your sticks and stones. You throw them my way to make a point, but I don't have hollow bones, so you'll never take away my voice. You used to be like home, but now the whole place is so destroyed, and I'll survive on my own.
Let's see here real quick. Sorry, just need to check. Oh, wow. That's actually working. To some extent. All right, success. I guess we're good. Anyways, moving on. Here, we're supposed to also insert M3 nuts. Not gonna do that right now. We did the heat sets. That should be enough. And since we're not building the tool head yet, we can safely skip this stuff. The stuff we can't skip, of course, is the heat sets for the mini Stealthburner. That's going to be fun. Oh, but first, heat sets into the screws. Or the screw heads. These go on the bed, and they're used to adjust your bed height. There we go. Guess I need to hold this stuff away from myself a bit, if that even helps. These we also checked. There we go. And since these have a lip and that lip is not showing up, I guess they go in this way. Let's check real quick that we're getting far enough down. Yep, we can hit the bed of the press. Let's put those in. And let's rotate this just a tiny bit so we have a straight underground. Ooh. Yeah, no. And by the way, let's move you guys there, because otherwise the handle's going to get in your way. Yeah, it's going to do that anyways. And that fell below. Try not to touching the heatset, because it may be hot. Let me see here. There we go. That may be the ticket. Can't go further down. Take that off as well. And the last one. Fiddling the heatset insert is a bit difficult in that one, but since we're heating that up anyways, it doesn't actually matter if it's initially somewhat crooked. And there we go. Now the 3 parts finished. That's for applying the heater and the magnetic sheet. It's somewhat interesting to me that they are doing it in this order here, because if you do it like that, you don't have a good surface when you apply the magnetic sheet. Right, this heater is not flat, so I would guess that it's better if you do it the other way around. First the magnetic sheet that actually has a flat side, then you can turn that around, and then you can work your heater on. Yeah. No heat sets here either. Now we're getting somewhere. I guess we need to take apart our little cat here. Both of these parts, by the way, I will put up on GitHub at some point. These are not standard. You can see that on the front with the logo. I kind of screwed that up. It's too shallow, but this part's otherwise completely fine. So I don't see why I wouldn't use that. Same goes for this. The reason why they are not standard is this. That is actually a compartment for a switch for the filament sensor. The sensor is going to sit above the actual extruder. Thank you. Speaking is a skill that people may need to learn. Yeah, so this had to be modified. The filament sensor obviously was a mod already available, but it had to have cat ears. I can't do it any other way. I would have preferred dog ears, but cats are kind of cool too. All right, let's put in some inserts. Let's switch to the mobile cam here. Screw that thing. I actually have a really cool setup for switching the scenes on my tablet, but the thing was bought refurbished and nobody bothered to check that that battery was actually up to snuff. Spoilers, it wasn't. So if you're buying refurbished, which by the way I still would always do because it's better for the environment, you very likely don't need the newest and greatest and craziest gadget. And those slightly older ones are completely fine. But if your device that you're buying is too old, then you may run into some issues. All right, so this part is kind of harder to do because, as you may see here, we need to get our heatset insert all the way in there, and this tip is definitely not going to be long enough so the upper part isn't touching the plastic there. So what we're going to do is, of course, first, yeah, see that? That's already touching. So not a big fan of that. What we're going to therefore do is we need the other one. We are quickly going to take off this. Oh, this is the wrong one. Let's take the big one. Yeah, so we're going to take off the soldering iron really quick. That's too big. Whoop, sorry. That should be the right one. Yep. And yes, I realize that this is going to be hot, so some care needs to be taken. The good thing is that this moves out down. So at least we're not touching the printed part. Don't do that at home, kids. And yes, I have done this before. It works without burning myself much. We can also turn this to the side. There we go. We already took out the, and now what I haven't done before is the same thing with a camera in the way, but we'll make it work. Anyways, we don't actually need to take it out completely. The only thing we need is the tip of the soldering iron. And I'll move you back to the mobile cam. That did not get skewered this time. And we're gonna push these in from the side. Takes a bit longer though, because now we're not connecting as well with the surface. So it takes a lot longer to transfer the heat. We're just gonna keep it here until that heatset insert slides in by itself. Shouldn't be a big deal. See? The skill will be to get this straight. And at this point it would probably be cool if we had something to press it down straight. Now this already looks decent. It's still a bit above. Gonna do the next one. Let me see if I can give you an angle that you can actually see what's happening. Yeah, so this obviously takes a while. And you actually don't want to force them in, you want the plastic to melt around them to really keep them in there. If you just push them in, you're actually destroying the structure, and I guess that's not the goal here. The iron, by the way, is set to 250 because that is the extrusion temperature of this material, and I figure that's exactly what you want here. The actual temperature around the heatset's probably going to be a bit lower, but should be fine. All right, and this last one is really fickle. Maybe I can show you this. There it is. Now, how do I get my soldering iron in there? There we go. The problem being that I can't see anything now. Yeah, that should be fine, I guess. That should work out. There you go.
Me and you and me was a dream at first. I got lost in your world, in your universe. I never thought our love would ever end. I messed up, made it worse, pushed you away. All that fighting and pain till you left one day. Wish I could take back all those things I said. I can't deny that I miss you, and I know that you miss me too. So let's get over our issues and go back to me plus you. I know that things weren't perfect.
What we can do now is actually take a screw. Bit of a balancing act here. Haha. Oh, actually, let's take something longer. These are kind of short. Yeah, these are good. Because we also don't need to screw them in. And if we take these, we can actually check how straight our heatset insert is. Guess that's fine. Well, actually, that's a bit crooked. We may want to adjust that. There we go. Heat it up. Oh. Balancing act again. And yes, I will burn myself on this stream at some point. And maim and poison myself probably as well. Cool. Let's check the next one. That one's actually still a bit high. Let's put that in somehow. Maybe a bit further. I always wonder if these actually needed to be designed this way. It's something that makes the barrier of entry a bit higher. Yeah, that's crooked. Yeah, it's completely crooked. The problem, by the way, and why you shouldn't try to force this with screws is because that screw will immediately cool down that heated insert, and then you again don't have the plastic flowing around the insert, but instead somewhat being strained. Still crooked. There is the option of course, just heating up a screw with like a lighter, using that to push in the screw. Not sure if that's all that safe, because in the end then you have a hot screw somewhere that you still need to deal with. So yeah, safety is a concern. Rather large one for me, because I am actually working in the field. We are making VR safety simulations. Awesomest job in the world. But you get somewhat sensitive to this stuff. Yeah, I mean, still nobody here, but if you enjoy the recap or the recording, let me know in the comments. Maybe next time you'll be there. We can have a bit of a discussion about all the things you don't agree with, and maybe about the things you do. That would be awesome. And yes, this is probably on the level with a screw sorting stream, but you gotta start somewhere. And then we have it behind us. Heating that up again. This one's really awkward. And yes, I'm not the handy person. I'm pretty bad at this stuff actually, I guess. But that's why we're doing it. Right? I want to do it, you want to see me screw up. It's all content. And I think I just grazed the printed part there with my soldering iron. Damn it. It's still gonna work. And that's a bit too low, but it's fine. As long as it doesn't come out the other side. Yeah, that's good. That's workable. Let me put back that screw. And no, that wasn't hot anymore. It didn't have that much heat transferred. Let's check where we are. There you go. And the next part is the insert for clamping the filament in. That is also a part we already saw. others, these standoffs, we're not gonna do. A, because they are not needed for the Fysetc kit, and B, because even if they were, I would not touch those with a 10-foot pole. They just don't work. They printing those well is probably, well, at least in my experience, on the level of doing Olympic sports. It's if you find somebody who can print them well, feel free to use them. But I tried a couple times, even with the best attempt, like layer adhesion on those was just not good. And because you print them in their weakest orientation, they just tend to fall apart. I guess that's another, well, somewhat another part somewhat in the need of a redesign. All right, this part though works well. And we need an insert. And in this case, because we again don't have a flat registering surface, we also want to use our vise. I always wish I had freehand. Freehands would be so much better. That did not work well. That also didn't work well. Let me move you to the other side. That was kind of a good orientation. Except for my Corona belly. Yes, Corona wasn't kind to me. But it's getting better. And as you may be able to see, I'm actually standing right now. Standing desk for work as well. Very best invention. I'm not sure how we ever were able to survive without. Especially as a software developer, if you're sitting all day, it's just no good. For this stuff, if we later have a printer on the desk, we can actually move the desk down and have it in a better position. So yeah, it's awesome. Cool. That we got done. Let's go 1, 2, 3, and 2 at the bottom. Sure. Here we go. Cat ears turned around. The one in the corner might be somewhat awkward. Do we get, no, we also need to adjust the height. Yeah, that's pretty good. And maybe we can even get this a bit closer. There we go. That looks good. Second one. By the way, this press also has the ability to actually define a height and then stop. I have yet to use that successfully though. Not because the stop isn't good, but because it requires realignment every time. And obviously you don't want to do that against a plastic part. So yeah, not sure how much sense that makes in case of any heatset press. I kind of wish that there was an attachment here. I may actually print something like that. That you can use to register against. And once you have, you get to then push in the actual insert. And by the way, if I'm talking like an idiot, that's because I'm still getting used to the monitor in my head and that kind of repeating what I say a second later. I'll have to look for a solution for that, but I kind of figured that it's better to monitor your audio than not. First time I'm doing this though. Didn't see any to delay the stream, just to get used to. Oh, and we need to actually do some more here. I really hope that those noises are not bothering you guys as much. But I guess they will. Complain in the comments. I may or may not apologize. And by the way, the reason why I'm doing this on the stream is because we're going to do everything on the stream. We're going to do the wiring, we're going to do the installation, what have you. And if we struggle, we struggle. Not sure where we would, but life sometimes throws the things. All right, so next. And yeah, if you're bored, talk to me. Next time, obviously, this time you need to sit through this screen, through this stream, and just listen to me waffle on about things I'm doing and no interaction whatsoever. Next time, just join if you have a problem with that. All right, this looks good. Let's look at whether we actually have those parts. By the way, the reason why I'm doing that is because A, you should, and B, I printed this quite a while ago, and we definitely need to be sure that we have everything. So that and that I know. We definitely need that. I also see small parts for the feet here that we should have taken out. For the doors, the cable guide we will need later. But where is... That's gonna get some heat sets as well, I guess. So we can already put it out. Actually, I can. Oh no, I can't actually show you because the heat set is in the way. Let's move that back. Just a tiny bit for now. And let's not put the cardboard against the hot iron. Otherwise we may need our towel and we may need a fire extinguisher. The first obviously being mandated by the Hitchhiker's Guide, and the second one by actual safety regulations. If you're in Germany and you're working from home at least. Oh, look at that. There we go. Such a smart pot. Giving us such big trouble. No heatset inserts, but at least it's there. That we don't need to deal with. That part we already have here. The other part, this has a bit of a bad case of elephant's foot. Maybe let me show you this here. You see that there? That is one fat elephant. Right. Definitely looking forward to this part. Supposedly this is much easier now than the Afterburner, as judging from stories that Nero and co are sometimes telling from the war. So yeah. We already got that. Need to exchange the hot end though. That part we're not going to need. And the standoffs here neither. We are going to use the Fysetc. Actually, we have those parts. Right? But Fysetc actually gives you one of these that you then use to put in your board and screw that against your motor back. So you get a nice little case. Not sure how I feel about that yet, though. Yeah. Cables. This is stuff where I'm potentially more at home than all this manual building. So this is the part that Fysetc actually said we should build. Looks slightly different. I may need to consult their instructions. They actually have separate videos up for how to do these. Should be fine, but we can at least... Well, do we want to? Yes, we want to put those in there. So, there we go. And I need to switch you guys over real quick. Next time I will have the whole Stream Deck / Alfred setup properly working. This is not far enough down. There we go. That slid off. I guess I got lucky that that heatset insert is sitting so well there. And yes, if you see me retry these and just push them in a bit further, I just want to make sure that they are flush or below the surface, because I can actually see it. You know, who cares? It works. That is done, I guess. Ooh, and then it's wiring, so I guess we're through with the printed parts. Let's quickly check that. All the skirts are actually not using printed parts. Not printed, not using heatset inserts, obviously. So who would ever think of saying printed parts in that situation? That would be weird. The cable guide. All right. That we have as well. I'm going over these parts quickly because they will not influence us as much, or we will not be dealing with the panels immediately. This printer is very likely to print PLA for at least a week or a couple of weeks before it goes into its actual service. Reason obviously being that it needs to run in, that it needs to, I don't want to say burn in, because if I do, it's going to burn in something. Probably gonna burn down the house. No, we're not. What we also need to heatset insert are these. Very clearly visible on the hole size. And by the way, they are for this, I think. So if you want to mount these, they go in there. So here's a funny twist. Those are not heat sets. Where are they? What part is that? Oh no, they are not heat sets. They're magnets. Reading. Reading helps. And then those magnets actually connect to the others. Okay, okay, nice. That's the top hat. All the panels get screwed on. Cool. I guess we have everything we need. Let's clean up the mess. And once we do, we can get started on the frame. Let's go, let's go, let's go. Let's lose any parts, because the dog will bring those to me. He will chew on those though, so they will get a bit of a personality. We're not gonna need the vise. We're definitely not gonna need a soldering iron yet. Let's turn off that. We don't need... Oh, we still wanted to Heatset press those. Also, feel free to comment on the choice of music. And I guess we didn't get all the farthest until now. But yeah, dirtling. Right, with this part we actually on the backside have a problem, because they were printed with a lot of elephant's foot as well. So I need to clean those up. Let's do that in a second. First, let's get these. Something to clean up there as well. And now, one of the best tools, especially if you're printing with a lot of elephant's foot. There we go. That should do it. I mean, you could always press those in without actually cleaning up the holes first. It's just a bit easier if your heatset insert sits in the hole already and not somehow on top of it. Especially since those on top may scroll and flip around. You'd have to really hit those square on or straight on. There we go. Another part done. And yes, I'm aware those are hot. Shouldn't do any damage though. The whole table surface is actually covered in somewhat heat resistant material. There we go. Yeah, I think the cleanup I will actually do off screen. No need to bore you guys with that. If you're still watching, you already sat through almost 2 hours of prep. And heat sets. So it might not be the thing to do. There we go. Now we can turn off the iron and move on. This thing goes to the side. Our printed parts go in here. That screw might need a home. Going to be so interested in watching this video again, seeing what the audio quality is like. There's probably a lot to do for me to clean that up. That part as well. Cool, that's prep. We did our duty for Queen and Country. And yes, that is a quote from Doctor Who. And this is probably gonna be loud again. Oh, no, actually. There we go. Quick and easy. Nice. So, next steps. We need to go back to the beginning, because now it is time for extrusions. The most difficult part of building a 3D printer is usually getting it somewhat square. You can definitely overdo that, and you can definitely make your life easier or harder. So what we want to do is first figure out which extrusion is which. We want to mark those. And I need to get some tape to be able to actually do that. And once we have those marked, we want to check if there's any optimization we can do to getting those as much the same length as possible. So here's a bit of tape. Now I need a pen. The question is, where do I have one? Oh, actually, that does it. That does the job quite nicely. Let's move the mobile cam away here. And let's look at the extrusions. We are supposed to have one A that does not have any holes. No holes. Oh, and it's not supposed to be tapped as well. The question is, yeah, let's have a closer look. Let's see if that can focus. Otherwise, I may need to put that up even further. Oh, there we go. That looks like tapped. Tapped. Well, let's maybe first remove the ones that have, for example, holes, like our 2C extrusions. Let's sort them into things that have holes and that have none. Move from there. No holes. I'm just gonna bring you back. There's one hole. There's two holes further out. No hole. Two and one. This is 2 and 0. This is the same as this. Two holes in one. And I can actually bring you guys a bit closer, I think, so you can see what's going on. Right, so this has one hole there, none there, but if we turn them on the side, they have two. This has one hole there, one on the other side as well, but no holes on the second side, and these have both one hole there and nothing otherwise. This has one here and none otherwise, so that's one of these. No holes. Also no holes. Holes here and there. And by the way, this fluff here seems to be some kind of I don't know, adhesive, something well not permanent, but it is on a few of the extrusions. Not sure if there's any explanation behind those. That's a no hole as well. One hole. Two. And this should be one. Yeah. So let's maybe have a quick check on how well they are cut. And by the way, I'm just doing this just with the fingers. I guess with these we don't have any choice anyway. They're just gonna go on in any direction, but they're fine. That there's almost no lip here when I'm having them directly at each other, so they're cut pretty good. Yeah. With my Trident, I actually had the issue that I had 6 extrusions for the Y, and 2 of them were just slightly longer than the others. And hint, put those at the very top, because there they just don't matter. The very top, if you ever build a Trident and you have a similar problem, the very top just doesn't matter. Everything else contributes in some way to the square of the printer, but the top ones, push comes to shove, those get bowed, or they try to stretch the middle ones and they can't. All right. Yeah, those are perfect. They're way better than the ones I had in the Trident, to be honest. And even the Trident ones aren't bad. You just need to make sure that you sort them into equally length or like equally sized ones, and that kind of helps you with the squaring already. Or you just don't care because you're spewing molten plastic. That may be the way to go, actually. Yeah, almost no lip. Cool. So what we're gonna do now, just for reference, is we are going to mark our extrusions. It just makes it easier to identify them and to work with them. Just try not to cover any holes, and potentially try to not cover the sides that rails are put on, although this stuff's not permanent anyways, so I guess it's fine. And I can actually pull you back out here. Yeah, this will actually stay on even for the next stream, so it helps get back into it. Oh, I'm looking so forward to food. I made the mistake of actually eating something that contained gluten, apparently. So, yesterday. And that did not sit well with me. So I had to take a day of fasting to get myself into a state again that I could stream without having my stomach constantly rumble. And yes, I know it's going to be a bit harder to actually write on those now, but we're not writing books or letters, so it's going to be fine. There we go. And what do we have here? The extrusions with 2 holes in one direction and no holes in the other. Those. They are the C extrusion. That's gonna stay. We have the extrusions with the 2 holes in one direction and 1 in the other. That's these. Those are the D extrusions. Oh, and somebody wants his food. We have the short extrusions. By the way, these 3 and these 4 we're not going to label, obviously, because these 3 I think we don't need. These are for the top head, so they go like this, and then you get the other extrusions to connect those. But the 3 extrusions here, even though Fysetc gives you the CNC part, they still include those. So these are for your bed. That's kind of nice if you really want to build something stock. I mean, there are a couple of differences, but they give you just about everything you need. It's kind of nice. Okay, now we need to fiddle around with these and figure out which is which here. Let's look at that. One A extrusion, 5B, so 6 in total. Oh, we can actually do these first, because these are E. There we go. Oh, sorry. Quickly do those up correctly. And by the way, the reason why I'm doing it this thoroughly is because I don't want to have to reference the front of the manual every time. It's just annoying. Alright, the reason, by the way, why we have 9 here and not just the 4 and 1 that's referenced here is because we have, or 5 and 1, no, then it should be 10. Or 10. Is because we also have the top head extrusions here, which, judging from how the top head is built, need to be drilled or tapped as well, which means that they would be just the same as the B extrusion, which means that there's only one single extrusion in here that's not tapped. And to be honest, if I were manufacturing this, I would not include an untapped extrusion at all. Whoa, sorry. Because it makes it so much easier to just have them all be the same. Even from an inventory perspective, that should actually be the easier option. So those are tapped. Tapped. Look at that. They actually did not tap that one. double check with the last batch. There we go. So this is A. And by the way, this A extrusion, the reason why it's not tapped is because it is your X rail, I'm guessing. Because that would be the only extrusion I can imagine that doesn't need tapping. Because you're basically holding it between printed parts from the top and the bottom. So, fun fact, these two, either of these you're gonna use to be your X extrusion. And these then obviously become Bs. There we go. There we go. That is it for prep. Now we got about an hour to 1.5 hours left. I guess we can start building a frame. And for that, obviously we want to go back to our manual here. We got our extrusions. We got our extrusions labeled. We know where things go, roughly. Let's see. All right. So, G extrusions we already covered. H. Oh, wait. I think we're getting ahead of ourselves a bit. B, C, E. The F are the shorter ones. G extrusion is also a shorter one. Those are all these that we need for the bed. So F and G we don't need. But H is mentioned as being 2 extrusions. Oh, we already got those. All right, we're good. No, we're not. Give me a sec here. I got 2 of these. 2 holes, no holes. Tapped. 7.5 mil. 2 holes. No holes. 7.5 mil tapped. Oh no, 7.5 mil not tapped. Oh. So we need to take another look at our C extrusions. because 2 of those are supposed to be tapped and 2 are supposed to be not tapped. Interesting. Let's see here. These are all tapped. So that's something that somebody needs to explain to me. Why would Fysetc go and provide me with 4 tapped extrusions, even though I only need 2? In case of this H extrusion. And the C extrusion. But at the same time, does not tap the A extrusion. I mean, the A extrusion and the B extrusions are just about the same. Interesting. All right, and obviously we get told that we don't need the G and H extrusion when we build with the Kirigami bed. This just as much applies if you build with the CNC bed that Fysetc includes. And by the way, not really sure what's better there. I may actually prefer the Kirigami bed because I kind of figure that that might be lighter. All right, cool. So we're dealing with the rails now. Guess I need to grab those. And I also need to grab the PCB rail mounts. Oh, we got spare balls. I need to find the PCB mounts. Oh, and let me get you to a better camera here. You may have noticed that I'm not quite used to all this camera switching yet. I promise to do better. Where? Oh, I see him. I see them. So these are the dreaded PCB inserts. word is that these are very, very fragile and that they need to be treated that way. Otherwise, it's really easy to strip them. Interesting, by the way, that Fysetc chose to leave them open on one end, or on one side, and with those standoffs, they put Kapton tape over them on the other hand. Why? Interesting. And we are getting 1, 2, 3, 4, 5 nuts loaded. Kind of interested to see if these are enough. Now let's check our rails. See what's going on here. And I definitely need to get used to that audio monitor more. Kind of feeling like I'm talking like an idiot. Actually, this feels very good. It has a slight coating, but I think I just run those as they come out of the packaging. Yeah, that feels really good. And I know that the grease they put on here is more for rust preventative. Do I really want to take those apart? The problem with not doing that and not properly greasing these is that we don't know what they used here, and if we don't know the grease they used here or whatever else, probably shipping grease of some form, we may run into trouble as soon as the device heats up a bit, and that may potentially also result in then decreased performance as soon as the printer is hot. And we want the printer to be hot. Especially for ABS, and in this case what this printer is going to be printing is a lot of nylon. We want that to work stably at temperature. So I guess we need to degrease those. yes, we already need to fix those, so we either do it now or never. And by the way, let me grab the rail guide. I'm kind of feeling like a kid playing with Legos. Like having this big box of Legos and then just trying to find the right part. Not like today's Lego where you get everything packaged in this set of plastic bags, and you basically put one plastic bag out and you only have parts that you can easily distinguish in each bag, so you can just go from bag to bag and easily put together the models, right? Back then when I was young, you'd sit there for hours and you'd try to find your parts. By the way, I'm just putting the display back together because they kind of got pulled apart. Just to make sure it sits somewhere that it's a bit more secure than just flying around. Alright, so I guess we're doing rails. Let me clean up the mess real quick. Sorry. Don't need all this stuff. It would have been way better if somebody was here. That way at least you could tell me what I'm doing well and what's kind of stupid or too loud and not. But I guess you will just need to live with my mistakes. For you, I guess. What do we need? We need some kind of pot. I distinctly remember designating one. I can't remember which one. So I'm guessing we are going with a non-reusable. And we need some IPA and some wet wipe. Well, no wet wipes. Some kitchen towels. There we go. We got the IPA. Now what we also need is grease. And here's the interesting question. Where the hell did I put the grease? Excuse the noise. I need to dig through a couple drawers. Oh, and I think I know. Yes, look at that. That, by the way, being, in case you're interested, Tepco Automotive. It's just a universal grease, obviously written in German. And it's an EP2 grease, which means that is more stable under pressure. It works better in pressurized environments, which your printer may not be but push comes to shove, I'm not sure how a non-EP2 grease would behave in case of a printer going burr really fast. You know how that goes. Anyways, IPA, there we go. Because we don't want that to touch anything else but our rails. Don't take a sip, because that might not be good for you. Well, actually, it's probably the best alcohol there is, or at least the purest alcohol there is. But due to the additives, it is not food alcohol, and you probably vomit that stuff out quite quickly. So the thing is, we want to degrease these. We want to degrease these first, and we are going to keep the carriage on for that. We're just going to agitate it until we get most of the grease out. Then we're going to take the carriage off, dry it off, and yeah, re-grease it. The reason for why we want to keep the carriage on, obviously, is because we don't want those balls to then jump around the IPA. So what we're going to do is we're just going to agitate it. This should be enough because the IPA will displace the grease. So displace and dissolve. So we don't need to do anything extra. Need a bit more in there, it's just too uncomfortable to work this way. And I guess that's another bottle of IPA gone. Although, to be fair, this stuff you can probably reuse. There's barely any grease on these rails. So the stuff that's in here I would probably still use for some light cleaning. Not your print bed though. That you want to potentially have cleaned with proper IPA. But like, I don't know, stuff you just want to clean to clean it. That doesn't necessarily need to be all that clean, but still want to, where you still want the dissolving effect. That should be just fine. All right, and by the way, don't trust me with anything I do here. This is the second time I do this. Go watch Nero if you want to get the full lowdown on how this should be done. This is me. And by the way, now they sound somewhat different. Or this one at least. And it moves. Well, it actually gets stuck a bit here there still. But in general, it moves lighter than it did before. And I'm still talking like an idiot. Damn it. Yeah. So that one's clean. This one still has grease in it. Light. But do you hear the difference? This one sounds harsher, which is exactly the effect that grease should have. It dampens and lubricates. And by the way, that's also something I would be pretty interested in knowing, is how does grease affect your input shaper values? Because on the one hand, it should dampen the movement and any frequency resonance in the movement. On the other hand, it hinders the movement. So yeah, put it in the comments. Probably gonna be drunk soon because I have my fingers in the IPA all the time. Gloves would have been the thing to do here. Gloves, yeah. And I guess this is a prep screen, prep stream then. The whole monitoring throws me off. But hey, we're gonna get there. I'm gonna get used to this. Probably gonna need to learn to ignore myself until I don't hear myself. But I hope at least the music's good. Yeah, and by the way, I don't actually need to leave them in there all that long. Because even while they are out here, the IPA will still do its thing with the volume it already accumulated inside the carriage. All good, I guess. Yeah, these, hear that? Way harsher than before. All right, 2 more to go. Anyways, to the topic of input shaper, I think it may actually be better to pack your rails more than less. You only want to pack them with grease where you actually have the balls, but push comes to shove, more grease is better than less. I have seen people push grease through the hole in the extrusion though, and I kind of figured that's probably not something you want to do. The reason being that the less grease you can have on your rails, the better. And what's actually driving and riding those rails, if I understand those linear rails properly, the thing that's actually riding on the rail is only those balls. The other things should actually have a bit of a distance between them and the rail. So the only thing that actually needs lubrication should be those balls and the races they run in. Now, again, I may just be talking completely out of my ass here, but I figure that's the part that actually needs greasing. Now you'd say, like, what's the downside of having the other things greased? Yeah, I'm actually building bikes in my spare time as well, and there you try to not grease things that you don't have to. Like, for example, try not to leave any, in that case it's oil, not grease, on your chain, right? You want to grease those chain link connectors, or the inside that actually moves. But you do not want any oil on the outside, because that then collects dust. And if that collects dust, it wears down quicker, and it results in the chain elongating faster, which I kind of figure might be the same thing here, especially if you're not enclosing your printer and you have too much grease on your linear rails. You may actually decrease their life just by giving an additional rough surface, or like something that can collect dust. And I kind of figure that's not something you want. Oh, that one's a bit crunchy. By the way, I hear the thing to do is the most crunchy rails in the Z direction, the least crunchy rails in the X direction. Since we're likely not going to get to any frame building today, because we still need to take apart, grease, and put back together these rails, I will need to look up whether this is actually intentional or not, because this at least feels very obvious. And I'm kind of suspecting that I will also find that those balls will jump out at me, and that I will need some tweezers to get them back in. That would suck. Yeah, cool. I guess I need to change the numbering of this stream to 0, not 1. Because we barely built any printer, we just did some prep work. Prep work that others usually do off the screen, but I guess now you saw it. Cool, those are nice. There's a noticeable vibration in there, in this one. Yeah, let me see if I can find another one. Let me see if I press it in one direction. It's still noticeably vibrating when it moves. This not so much. This is good. This is really good. See about that one. Okay. I think I got candidates for the Z-axis. The reason being that your Z-axis moves the least and requires the least jerky movement and the least speedy movement. So these two show noticeable vibrations when moving, so they become our Z-axis. This is so damn smooth, and like that there's no grease on that left, but it's dang. Yeah, this is going to be our X-axis. Cool. Let's pull them apart. So you please do not do this if you're not comfortable with it. I'm not comfortable with it. I'm gonna do it anyways. Turn them around, and then very slowly pull out these arrays. Actually, what I'm gonna do is for soldering, I have this magnifying thing. It's not gonna look sexy, but who gives a damn? The point is, it's got magnification on it, and a lot of it, and additional light. So especially in cases where I'm dealing with really, really small stuff, since I'm also not seeing as well as somebody else, this helps. In case you're getting old, this may help. Anyways, there we go. And let me put this away. Also, you don't need to fully pull out the rail. You only need to pull it out as far as you need to actually grease this. And don't exert too much pressure on it, because you may just pop out those balls. What you want to do is you want to push in the grease into the hole where the balls slide in. Then you want to pack the rest of the race, at least as far as I figure. So those balls are not moving on their own again. That should already be enough if you also put a slight layer of grease on those balls themselves. And obviously do that for the other side. And again, try to not exert pressure on the balls themselves. No pressure on balls. Right, if you look at those races, there's actually not a lot of space in those anyways. So you only want to fill up that space with grease, and you don't necessarily need to fill it up fully. Right? If you fill it up too much, you may actually get some binding. I'm not sure if that's a good thing. All right. Thinking maybe I can show you this a bit closer, but it's rather difficult to do, rather difficult to capture. Let's see here. Maybe the mobile cam can do some good for you here. Our mobile cam might be out of juice. Let's see if we can revive it here. It said something about only having 3% of battery left. I guess it's because I'm doubling up on USB-C stuff. It might not have gotten enough juice to do its thing. And there we go. We already got that greased. And now when you put it back in, carefully, don't exert too much pressure, and watch out for those balls. They need to run in the races. You may push them forward somewhat, but don't do it too fast. There we go. this is packed so well that it does not move on its own anymore, which means that it's going to be really, really stable in the X direction and hopefully will not exert too much vibration. Obviously that's going to be really good for print quality. Although, again, spewing molten plastic. So who knows if this voodoo even does anything. Turning that around. All those balls look like they sit in there really well. Let me do a bit of a nosedive. Can I actually get you guys to see this better? There we go. I mean, it's not as close, but it's probably the best I can do. If you expect some production value here, sorry. And yes, it's pretty hard to actually look up and see if you can really see something here. The whole contraption on my head makes that kind of difficult. And obviously I don't want to pop my balls. Okay, that was a bit too much. Now we have some grease in the race down below. That's actually what we don't want. We don't want to grease the top or the bottom of the race or of the carriage. We just want to grease what's running. I figure, again, not a pro. Let's wipe off the excess. Put that back in really carefully. And by the way, you see here is the result of actually applying your grease very, very targeted. We still have some that got spilled over and pushed out, but it's by far not the full rail. And that top side of the rail is probably going to remain reasonably clean compared to the rest. And once we move that around a few times, all those balls will be greased. And that makes for a perfectly finely greased rail. And yes, it just takes a while to really agitate that grease into every single nook and cranny and every single corner. But once every single ball went through the grease, it's gonna be feeling really good. By the way, absolute pain in the ass to get grease in these. And don't put that in a vein. That's probably not healthy. Oh, by the way, difference. Ungreased, greased. For those sound aficionados that actually appreciate all the noise I had running through their heads. I'll see about having something to suppress that in most instances. All right. 3 of 5, not 7 of 9. Actually 9? You'd have to build a K3 with a trident Z-axis to actually get 9 rails. I think otherwise it has 10. Not looking forward to building that thing in the sense that greasing those rails will just be a pain in the ass. And yes, I will be building one of those. It will depend on you and how much you engage with this stream and these weekly sessions on whether I still deem it necessary to take you along. Although I probably will just start streaming anyways. There we go. Oh, that was close. Almost lost my balls. Oh no, I lost the ball. The ball jumped. Dang, getting that back in there. I guess it's packed enough. Let's see here. So, in case your ball jumps, tweezers. Don't try to do this with your hands. You probably just knock out another ball. And if you're sick about hearing about my balls, put it in the comments. There we go. See? Everybody makes such a fuss about jumping balls. It's no big deal at all. And even if you lose one, as we saw earlier, we actually got some replacement balls. Cool. Oh, what you also don't want to do is you don't want to pick up your balls with a screwdriver. Because then you magnetize them. And that may result in those not working well at all. Try to keep your balls as far away from magnets as you can. Ooh, that's getting smooth. It's already way quieter, but it now has a bit of a crunchy feeling. I think there's a bit too much grease in there. Nah, I don't think it matters. The important thing is that it's, well, actually that's a lot smoother. That's also a lot smoother. Ooh, what to do, what to do. I guess we just need to rely on that equaling out. Probably skill in itself to get the amount of grease right. I don't think we picked up any debris, but this now does feel a bit crunchier. Might be worth redoing. We'll see. Let's do the other ones first. Maybe one of these turns out to be the answer to all our prayers. And then we're just gonna use this one as a Z. Or that, I should say. Dang Americans. Screwing up my alphabet. Love you guys. All right. Get those balls out of the way. I would so like to take you with me here, just to show you what's going on. It's a bit hard though. Grease, grease, grease. There we go. That one as well. Third one. That is good as well. And by the way, yeah, there are rails with a grease port, especially if you ever plan on maintaining your printer. Maybe go for a speed bench here or two. You may want to consider getting one of those. These rails here, I don't think they have grease ports. There's this little port here, but I'm not sure that goes anywhere. Well, actually, port's a bit of a stretch. This, if you look, well, wait. If you look right here, by the way, there you go. That's my balls. And there you can see how I pushed the grease into those 4 openings. And here at the very end, there's this little mini hole, but I don't think you can use that as a grease port. Might be worth getting one with a grease port. You might not even need rails, you just need the carriages, although I'm not sure what the pricey thing here is. Again, no clue at all about all this stuff, just winging it. And it boggles my mind that in all this time, on a public stream, nobody even stumbled in here by accident. Is that really the case? Or am I just doing something wrong? Put it in the comments. If you're here, I want to hear from you. Looks like there's nobody here. Wow. Well, We could have had some fun together. Next Saturday, same time. Well, the time was about 7 CET, so I figure it's 6 UTC, which is so 6 p.m., which should be around 10 a.m. East Coast. For you West Coast people, sorry, you're screwed. You got to get up at 6 if you want to catch this. But yeah, just about nothing I can do about that. Huh? All right. Okay. Let's see how this one turns out. In the end though, you always want to use your best rail for your X and your second best rails for your Y. We'll have to see how we do this if the Y rails are so different. And I definitely feel some slight vibration here. So I really want to use these as the... I may actually need to redo this one. This one was actually the one that we said may just have too much grease in it. Yeah. And by the way, they may wear in as well. And by the way, let me put you to the mobile cam. Right, they do wear in some. The more you print, the more these balls will lose any kind of small imperfections they have. Same goes for the rails. So, by the way, that's also a reason why you want to wear those in before you do any kind of input shaper testing or any larger fine calibration. Because if you don't, you're going to do it again. Well, if you don't wait, you're going to do the calibration again, that is. Interesting. Yeah, and by the way, when you're working with grease, wear gloves. Do as I say, not as I do. Oh, and do not pop your balls out of the race. That was kind of close. Be so interested in. Oh, there you go. Maybe you can see that. That should be enough. And we're going to close this up again. No, because this goes here, and I'm guessing I just lost the let's finish the rail first. Gonna push that back in here. Gonna be very careful to, oops, we already popped the ball. The interesting thing is that I don't know whether that wall goes to the left or the right. Oh no, never mind. We pop 2 balls. And we're gonna need the tweezers again. By the way, and these auto close. Very practical if you're working with any kind of small thing, like for example those balls. The trick to getting those back in is to, instead of pulling everything completely out, just pull it out a slight bit and then force them back into the race from, ideally from the bottom. Although you can do it from the top. There we go. Number 1 is in there. I'm just gonna do 1 each side. I so hope that's correct. Otherwise we will have one side that may potentially be binding because it has too many. That would be somewhat unfortunate. Pop that back in there. See? No problem at all. It does feel crunchy, or at least it does still show some vibration, and it does move a bit harder. So this was the side than it previously did. That's workable. Actually, that is very smooth. Lots of resistance. It kind of feels preloaded. Huh, okay. I guess this one's gonna be RX. Because like it's very slow, but also very smooth. Cool. So how do we do this now that we designated X, Y, and Z? You guessed it. Tape. Let me pull you here. Let me grab a pencil and let me get rid of this ugly frigging thing that without I could probably do nothing at all or build nothing at all. So thank you, ugly thing. And then let's quickly label our rails. Now obviously we don't want to put the label on the rail itself. If anything, we want to label this, and we definitely need to make sure that we take it off before we in any shape or form use these rails or screw something to the top of them. Whew, and I guess that's the first 4 hours gone. Pah. We haven't even built anything. Oh well. there we go. And I guess we can leave it at that. We did our APA first. Prepared our rails. Prepared our extrusions. Heat set everything, I hope. And yeah, threw a bunch of things around. There's, by the way, the cap. Next time we start with the rails. Let's hope we get a good chunk further then, but I guess we will. We did a lot of good prep now. Should be about 4 to 5 streams to get this completely set up, I hope. Because I am looking forward to that salad fork build. And as you may have noticed, there are a bunch of other things that we still need to build and fix. Like there's a bunch of filament buffers for the ERCFA. We have a few modifications to the Trident to make. We want to build a K3. Quite a bit of stuff. I guess we have enough content for at least this year. All right. Anyways, I guess that's it for now. You guys have fun. Let me know what you think in the comments. Share, like, subscribe if you're so inclined. Leave a dislike if you really disliked that stream. Yeah, thanks for playing. See you in the next one.